Welcome for today's session, Railfense cipher introduction and its C implementation. The Railfense cipher is a form of a transposition cipher. Instead of substituting letters, it arranges them according to a set pattern. In this cipher, letters are written in a zigzag pattern across multiple rows, and they are read off row by row to create the cipher text. This approach offers simplicity and serves as an introductory example of transposition ciphers. How Railfense cipher works. Here we are taking one of the examples for Railfense cipher. We are taking the plain text here, hello world. So these are the three Railfenses here we are using. So the letters we are taking here, H, E, L, L, O, W, O, R, L, D. So the letters we are taking here in a zigzag manner. We write the text in a zigzag, filling in one row at a time and reversing the direction each time we reach the top or bottom row. After arranging the text, we read each row to get the cipher text. In this case, the encrypted message would be H O R E L O L L W D. So this is one of the example of Railfense cipher. Let us take one more example here. The plain text we are taking, meet me after the toga party. So here we are taking the Railfense in the form of 3. So MEET meet me after 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 THE the toga TOGA PARTY. So everything we are fixed in the form of a zigzag pattern. So after taking this, we are arranging the text. We read each row to get the cipher text. In this case, the encrypted message would be MMTHGRETEFETEABPARTPY. So like this, we will convert our plain text into the cipher text. In the decryption, it can involve the reversing the zigzag pattern to restore the original text. We start by making the zigzag patterns based on the number of rails. Here we are taking the rails 3 and the length of the cipher text. This shows where each letter should go. Then we will fill in the letters by row to reconstruct the original plain text. This process through it involves tracing the zigzag pattern in reverse, effectively returns the message to its readable form. These are the steps for encryption. First, we have to set the number of rails. According to our example, we are setting the number of rails 3. Arrange the characters in a zigzag patterns across these rails. Then we can read each row sequentially to form the cipher text. These are the steps for encryption. The same in the form of a reverse, we are taking to decrypt the particular message. So here we can calculate the position of each letter in the zigzag pattern based on rail and direction. We can take the cipher text characters in their positions. We can read in zigzag order to obtain the original text. Coming to the advantages and disadvantages of Railfense cipher, the Railfense cipher is simple to implement, which makes it an excellent educational tool for understanding transposition ciphers. However, it's relatively weak in terms of security as patterns are easily identified with basic cryptanalysis, making it suitable for secure communication. Despite of these limitations, it remains a useful demonstration of the transposition encryption methods. So with this, we will conclude our theory part. Encryption and decryption we are doing to understand about the Railfense cipher. Then at last, here we are using how to implement the Railfense cipher. So let us discuss about the Railfense cipher implementation part. This is our program. So here, first we are including the header files here. stdio.h, console input output header file, and string.h for string manipulation functions, just like string length, string uppercase to lowercase. So for this, in our program, we are finding out this for string length function. Here we are initializing the sum of the variables here. So the variables we are taking here, I, J, K, L, we are taking here, and we begin by defining the variables A of 10, 20 and C of 20. A of 20 for the plain text and C of 20 for the ciphertext. Then D of 20 is D ciphertext. I, J, K and L we are taking for the counters and helper variables. Let us take the printf statement here to enter the input string. Let's say we are using to read the function of the input string, and to calculate the length of the string we are taking strlen function. Then this is for encryption ciphering. Here we are using this function, we are using to find out the first row of even indices. The characters at even indices of A are added to the first half of a C. For example, if we are taking the hello world, H, L, O, O and L would be added to C in the first loop. And in the second loop, we are adding the odd indices of A which appended to C, forming the second rail. The final C string, which is the ciphertext, is displayed here. For deciphering, we are taking the variable K, where to split C for decryption. The, if L is the length of the ciphertext is even, K is half of 5. So, if L is odd, the first half of C will contain one or more character than the second half. This loop copies characters from the first half of C into D, skipping every other index. And in this loop, we are copies characters from the second half of C into the odd positions of D. The D array now holds the original plain text here. This program terminates D with a null character to properly format it as a string, then displays the D ciphertext. Here we are using the getch, which is used to wait for user input before closing the programming window. So let us execute this program. Take the input string as HELLO, WO or LD. So we are taking the input string as plain text hello world. The ciphertext, after applying the Railfense cipher, here we are getting HLOWRDELOL. So after decryption, we are getting the same plain text by using the Railfense cipher. So this is our implementation of the Railfense cipher C program. The plain text characters are arranged in a zigzag based on even and odd position, forming the ciphertext, and the ciphertext is split based on the original row structure, placing characters back into their original zigzag positions to reconstruct the plain text. This program demonstrates the basic functionality of the Railfense cipher, a simple yet effective transposition cipher for rearranging the characters. With this, we have concluded our session. Thank you.